So, any homework problems that you've had problems with? Okay,
I'm on the same problem, the 12-part problem.
Yeah.
Anyway,
I got all of them right.
there's a 12-part problem.
Yes.
Okay, follow the steps to graph rational functions. Okay, maybe this is chapter 4, section 4, number 5. It says r of x equals x plus 4, x plus 6. Okay, needed. First, write the given function as a single rational expression. Then factor the numerator and denominator. It's done. Select the correct choice below. If necessary, fill in the answers. Actually, this one is just type it in as it is.
It cannot be that.
Oh, okay. That's ridiculous. Why put it up there? Okay. What is the domain of r of x? Select the correct choice. So how do we figure out the domain here?
I'm
Right.
Well, we have to first find these.
oh,
We want to find that.
Yeah, we'll find everything we can. So what are my horizontal asymptotes? What's my vertical asymptote? Yeah. What about this one? 0 and -6.
Okay.
Oh.
Okay. That-
There's
that-
because there's anywhere there's an x, you have to set equals 0.
It's just. It's just.
Right. X-intercepts. How'd you get that? Set the top equal to 0. The y-intercept. No. Right, there's none. Why? Because of this 0 out here by itself. If that turns into 0, the denominator is 0, it's undefined. So there is no no y-intercept. Well, we know there's no y-intercept because there's a vertical asymptote at 0. And that's the y-axis. Horizontal asymptote.
uh, hold on.
Because there's more x's on the bottom than the top. So this is 0. Because if you forget the numbers and one x cancels, we have 1 over x. As x goes to infinity, it goes to 0. So our graph, vertical asymptote there, vertical asymptote here, horizontal asymptote. X-intercept is at -4. So from this, you can tell me the domain. The domain deals with which x values. Good.
-6.
0. Very good. But let's see how the computer wants it written. So basically, all this thing says it's easier for us to put that x cannot equal -6 or 0.
I understand what's happening.
Well, because it doesn't give you the option for intervals. Because if this is a one-sided function and this is if there's multiple vertical asymptotes.
Sure.
It's easier for them to program the vertical asymptotes than it is to looking at parentheses and brackets and unions.
Okay, that's most fair. It's like, in terms of writing like this, that's just being asymptotes.
The
Right?
vertical asymptotes is, yeah, just
Because-
listing those. If you have any vertical asymptotes, that's your limiting of your domain. Write R of x in lowest terms. Select the correct choice below if necessary. Lowest terms. That is the lowest terms. Just a good job. Not nice work, it's a good job. Locate the intercepts of the graph. Select the correct choice below. If necessary, fill in all the blanks. So what we figured out is we have an x-intercept at -4, and there is no y-intercept. So it doesn't have a y-intercept, and it has an x-intercept here. Now, how does it want the answer?
Oh, no, it's X.
So it's 0 once, oh, not that. Okay, let's try that. See if that works. Yes, fantastic. Determine the behavior of the graph of R at any x-intercepts. Select the correct choice. The graph will cross the x-axis at -4 and touch but not cross the x-axis at x equals. The graph will cross the x-axis at that. The graph will touch but not cross the x-axis. Okay, so it's got to be one of these two. Will touch but not cross the x. No, just look for the intercept. Determine the vertical asymptotes if one exists. Select it. It's the same thing. The function has three vertical, no, the function has two vertical asymptotes. The leftmost is at -6, and the rightmost is at 0.
Oh, these we have to type, equations.
Oh, X equals.
X equals -6 and X equals.
That's ridiculous. Type equations. Okay, I should read the instructions, but still ridiculous.
It's okay. That's fine. So,
Determine the behavior graph on either side of the vertical asymptotes, if one exists. Okay. It approaches infinity on one side of the asymptote at x equals -6. Oh, let me see. So right, yeah. So it has to be A. So it goes to infinity on the, no, it doesn't. It goes to negative infinity.
So go to infinity on this, zero.
On one side.
Yeah.
Well, no, because if we look at our function, let's plot some points. Let's try at -7. That's going to tell us where we are. Because it's either going to be like this or like this. So at -7 plus 4, -7, -7 plus 6, -3, -7, -1. So the answer is -3/7. So the graph will look like this. And on this side, let's try -1. -1 plus 4 is 3. -1, 5. It's -3/5. So that means this side looks like this. And then at 1, so it's 5/7. That's what the graph's going to look like. So it goes to negative infinity as approaches -6 and positive infinity on the other one. And then positive infinity and negative infinity. So that hopefully is going to tell us on one and negative infinity on the other. Approaches positive infinity. Okay, so it approaches either positive on either side of the asymptote. Okay, well, we have two of them. I don't understand what they're trying to ask here because
If it was approaching either, then the middle one couldn't be there.
So I couldn't figure this one out either, and then it's gave me the answer, it approaches infinity on one side, the asymptotes at x equals -0, -6. Have it as like an ordered pair, we didn't have to put the parentheses around it.
let's put parentheses around it.
No,
That's what the first one said.
right, that's what I couldn't figure that out, is that that's saying the same thing, right?
Say it again?
A and B are kind of.
Yeah, because the only difference is here. It approaches either infinity or negative infinity on both sides.
Yeah, it is.
That's the same thing.
Right, it's,
Like also, it approaches positive or negative infinity on both sides of the asymptote at the two intercepts. All three of these are the same answer.
that's, okay, that's what I thought.
What the heck? That's crazy.
A little gaslit on my homework.
Whoever wrote that is an idiot. Yeah, I have to, let me see. Yeah, this is what part of, this doesn't tell you which part. The VA,
Oh, it's part
Uh,
7.
This-
Because we're party.
Oh,
okay. Part 7 sucks. I was gonna put it. Determine the horizontal asymptote if one exists. It's at y equals 0. Determine the oblique. Has no oblique, because you're going to either have a horizontal or an oblique. You cannot have them both. Determine the points, if any, at which the graph of R intersects the horizontal or oblique asymptote, if one exists. It crosses at -4. Type an ordered pair. Wow.
because it's kind of just asking like the same kind of
Over and
things.
over.
Over and over, yeah.
Because when I was going through this, I kind of just felt like it was
Okay, so determine where it's above, below the x-axis. So the graph is below the x-axis on the intervals. Oh, so it's this one. Okay, so it's going to be, yeah, -infinity to -6 union.
Oh, no, it's a second.
Oh, that's right. That's two answers.
Well, yeah, I need to have another answer in there. So, okay, use commas to separate the answers instead of union.
Okay, got it. No, it says, the graph bar is above the x-axis. And then the second part is below the x-axis.
Okay, so this one is -6 to -4, comma, 0 to infinity. And below the x-axis at -infinity, comma, -6. And from -4 to 0. It's this one. Yeah, it's not, this is another 12 point.
There were several of them on this one.
Well, let's do this one because the first one they gave us was already factored out. So this is question number 6, 4-4, number 6. R of x equals 7x plus 7 over 6x plus 30. So the first thing you have to do is factor it out. 7x plus 1, 6x plus 5. Seven x plus 1 over 6x plus 5. What is the domain of R? it cannot equal -5. Write R in its lowest terms. It's already in its lowest terms, since nothing cancels. Locate the intercepts of the graph. All right, so let's look at this one. We have the horizontal, the vertical, we have the x-intercepts, and the y-intercept. Vertical asymptote is at -5. That's 7/6. X-intercept is at -1. And the y-intercept is at 7/30.
That's the setting of.
The top equals 0. Right, because to find the x-intercept, set y equals 0. That means the only way of a fraction to be 0 is if the top is 0. And then the y-intercept is just set all your x's equal to 0. It's just the constants. It has x-intercept at -1 and a y-intercept at 7/30. It wants an equation.
Oh, so there's that -1, -2, right?
Oh, -1, I'm sorry, yeah. The graph, okay, behavior of the graph at any x-intercepts. The graph will cross the x-axis. Well, maybe let's go over here and graph this function. Which is 1/16. The horizontal asymptote's there. The vertical asymptote is at -5. X-intercept is at -1. Y-intercept is at 7/30. So what I'm saying, it's going to look like this. Oh. Just in case, let's go and plot some points. At -3. Yeah, so it's going to be negative, so that's good. Over here at -6. -6 plus 1, -6 plus 5. So we have to be positive. So yeah. All right, so that's the graph. The graph will cross the x-axis at -1. It will touch but not cross the x-axis. Nope, not gonna do that.
Crossing it.
It's only going to cross, yeah, at -1. But it's not gonna approach So, no. Determine the vertical asymptotes, if one exists. It has one vertical asymptote, and it is at x equals -5. Determine the behavior of the graph on either side of the vertical asymptote. It approaches positive infinity on one side of the asymptote at x equals -5. Determine the horizontal asymptote is at y equals 7/30. Oh, actually, oh, the 7/6, I'm sorry. 7/6. Why was it 7/6? Is because since the x's are the same degree, the horizontal asymptote is simply the coefficients. Yeah, I maybe had it there, 7/6. There is no oblique. Determine the points in which the graph R intersects the horizontal. There is no point in which it intersects. Because it simply approaches it but never touches. Use the real zeros of the numerator and the denominator. Divide the exponential intervals. Determine the graph is below or above the x-axis. So, from -infinity to -5, it's above. And then from -1 to infinity, it's above. -5 to -1, it's below. It's above the x-axis at -infinity. Where's that? -5, -1, infinity. -5 to -1. And choose the graph. It's C. Yeah, it's the hardest part of that one is just reading the question. Here's another one. I'm sorry, everybody. Want to do this one? Because this one, the numerator is quadratic in form. So this one is 4-4, number 7. R of x equals x to the 4th, x squared plus 10. Okay, we know what the bottom is going to factor out into. What's the bottom going to factor out into? Right, it's a difference of two squares. Now the top, what times what is 10? When you add them, you get 1. We can't factor it that way. So we got to use a quadratic formula. Remember, we're solving for the middle term in the quadratic formula. So we're solving for x squared. Negative b plus or minus b squared 4ac over 2a. B is 1, so it's negative 1 plus or minus 1 squared minus 4 times 1 times 10. One minus 40. Well, that's not going to be good because we have an imaginary term in the middle. So this is going to equal negative 1 plus or minus I radical 39 So we have no x-intercepts, no solutions. Because if the discriminant is negative, there are no solutions. Because we have 3 possibilities. Like this, and like this. If b squared minus 4ac is greater than 0, we get this. If b squared minus 4ac equals 0, we have that. If it's less than 0, we have this kind of graph. So we have no x-intercepts, which is going to make it more difficult to graph. So no x-intercepts. How about the y-intercept? Negative 10. Yeah, you just weren't finished. You said 1, 0. The horizontal asymptote and the vertical asymptote. Where's the horizontal asymptote? The horizontal, there's none. Because there's x squared under x, so there are x squared on top, so it goes to infinity. So there's no horizontal asymptote. Vertical asymptote. We finally have numbers. So our vertical asymptotes at negative 1 and 1. No horizontal asymptote. The y-intercept is at negative 10. So 10. We have no x-intercepts. Let's see what this thing's gonna look like. At those points, at -2. -2 to the fourth. -2 squared plus 10. -2 plus 1, -2 minus 1. 16 plus 4 plus 10. -1, -3. So it's 30 over 3, which is 10. What's going to happen at 3? So 81 plus 9 plus 10. So 100. -2, -4. So it's 50 over 4. 25 over 2, 17.5. So I'm thinking it's going to look something like this. +2 will have the same numbers on top. 30 over 3. There. That's the reason it really doesn't have a horizontal asymptote, because it, in essence, really has 2 of them at plus or minus 10. But yeah, I just went through those numbers, and the farther we go out, the higher it goes. The farther we go out, the higher it goes, which means this has something's going to happen on this side. Let's look at this. X to the fourth. Nope. Plus x squared plus 10 over x, x plus 1, x minus 1. Did you cover everything else already? Did you need me to go back on this one? You were still writing, weren't you?
No, no, no.
Okay. Okay, so the domain is, it cannot equal -1 or 1. Those are my vertical asymptotes. In lowest terms, it's already in lowest terms. Locate the intercepts. There are no x-intercepts. Well, there's a y-intercept. It is at -10. Determine the behavior of the graph. It's not going to cross the x-axis. It's not going to touch or cross the x-axis. There are no x-intercepts. The vertical asymptote. we have two vertical asymptotes. X equals -1 and X equals 1. Okay. It's the same as last time, is plus or minus on both sides. X approaches positive on one side of the asymptotes at, okay, yeah, so let's do -1, 1. Determine the horizontal, there are no horizontal asymptotes. Or we could say there's two of them. Let's see what they're going to say. Yeah, so since it's x to the fourth over x squared, there's none. No oblique. Determine the points in which it intersects the horizontal oblique asymptote, if one exists. Well, this one was easy so far. It's got none of them exist. Use the real zeros of the numerator and denominator to determine above or below the x-axis. So it's above the x-axis from -infinity to -1, and then from 1 to positive infinity. And it's below it from -1 to 1. Oop, I did, didn't I? Oh, right here. It's this one. How many more did I torture you guys with? Oh, that's the last one. The other one only have 4 or 5 steps. Okay, let's look at this one. Number 8. H of x is equal to x cubed minus 1, x squared minus 81. So how do we factor out these guys? The bottom's pretty easy, because that's 9 squared. So it's x plus 9, x minus 9. And the top is easy also because it's the difference of 2 cubes. The difference of 2 cubes is a minus b, a squared plus ab plus b squared. Only thing difference is if that's a minus, that's got to be minus, and it's got to be opposite. And if we had the a cubed plus b cubed, it would be a plus b, a squared minus ab plus b squared. The only thing different is the first two signs. The first sign is whatever's in the original equation. So if it's a cubed minus b cubed, we know it's a minus b. and the other one has to be different. There could only be one minus sign in the difference of cubes formulas. So this one is x minus 1, x squared plus 1x plus 1. So we have the x-intercept, the y-intercept, the horizontal asymptote, and the vertical asymptote. How about this now? What is my x-intercept? Yeah, it's just going to be 1. Because it's a top. This is going to give us a no solution because it's going to be imaginary. The y-intercept is very good. Because they're both negative, they cancel. Vertical asymptote. Horizontal asymptote. We have an oblique. Because if the top is bigger than the bottom by 1, it's an oblique. Because typically, if there's more on top than the bottom, as x goes to infinity, it goes to infinity. But if there's one difference, then we can do division. We could do long division. X squared minus 81 goes into x cubed plus 0x squared. We could do long division. So what times x squared is x cubed? Is x. And x times is negative 81x. Change the signs and add. That's gone, that's gone. So we have 81x and bring down this one. Oh, since x squared doesn't go in there, the rest is a remainder. So that's our equation. Our oblique asymptote is x. Yeah. And at negative 9, that's our vertical asymptote. And at 9, that's another vertical asymptote. X-intercept is at 1. Y-intercept is at 1/181st, is really far down there. So what do we do now? What? Plot points, yeah. But now we have to figure out also what happens out here at 10 and negative 10, at negative 1. At 2. So we're going to do negative 10. We're going to look at that. We're going to do negative 2. We're going to do negative 1, 2, and 10. We're going to get those points to see what happens, to get a better idea. So we have -10 minus 1, 100 minus 10 plus 1. -10 plus 9 is -1. So we have -11, 91 over 19. So that's going to be 110 plus 91. So it'll be a very small number, a very large number, negative. At -2, we have -3, 4 minus 2 plus 1, 7, -11. We 7, -11. Should be positive. 9 over 77. -2. 1 minus 1 plus 1. 8, -10. So it's -2. 1 over 40. Hmm. 2 minus 1 is 1. 4 plus 2 plus 1. 11. -7. 7. -1 over 11. And then 10. We have 9. 100 plus 10 plus 1. 19. 1. This is looking pretty weird. So at 2, we had -1 over 11. At -1, we had positives. Huh. So then we have the y-intercept at 1/81. So that's a little bit higher. It's interesting because there's this one's bugging me. Okay, then that's what it is. Then that's the graph. Because these points are getting higher, it goes here. It crosses at 1/81 there. It crosses there. So it crosses the oblique asymptote at some point, and it keeps on going down further that way. That's what I'm going with. Okay, so it's not simplified.
Does
It's
it want you to calculate it manually? Or is that just?
that's right. I mean, I had to see what the numbers look like because this, I mean, having no horizontal, you have an oblique. That's a diagonal line. And you have two vertical asymptotes, but so the top will be x minus 1, x squared plus x plus 1 over x minus 9, x plus 9. X cannot equal -9 or 9. Can't go any further. Locate the x-intercepts. The x-intercept is at 1, and the y-intercept is at 1/81. Determine the behavior of h. Graph will cross the x-axis at 1. I won't touch cross. Determine the vertical asymptotes. X equals -9. X equals 9. Determine the behavior. Oh my God. So asymptote. Positive infinity on one side of the asymptote at okay, it goes opposite directions. -9, 9. Determine the horizontal asymptote. It has no horizontal asymptote because it has an oblique asymptote. The function is x. It's just x. Yeah, I did that. Oh, I have to give the an equation, idiot. Determine the points in which the graph H horizontal oblique asymptote. Okay. So the graph x cubed minus 1, x squared minus 81 equals x. So x cubes cancel. Those become positive. Repair 1/80. Oh. Above the x-axis. Above the x-axis from -9 to 1. And below the x-axis from 1 to 9. What I do? And below the x-axis was 9. What it is. That's what.
And it's something like this.
There's not that one. It's the minutia that's going to kill you. But now you only have 4 now. Wow. Yeah, that one was. Those were. I'm sorry about those. I'll go through and get rid of a couple of those. That's just. That took a lot of paper.
So that would keep going with your opinion, so. Like, yeah, like if it was like half of that.
Yeah, 4, 5, number 1. This says 12 minus 4x is greater than equal to -12. Express your answer using set notation or interval notation. Okay. So. Be the same way you do equal signs. Subtract 12 from both sides first. -24. What's the next step? No.
Oh.
Get away from whenever you say divide by negative, never ever say that. Stop yourself. Bite yourself. Hit yourself. No. Whenever you have this, change everything. Because you have to change that, you have to change that, and you have to change that. Because if you divide by negative, that won't tell you to do this. All you do is change the signs. So you have to change everything across the equation. So this becomes a positive 4x. This becomes a less than equal to positive 24. Then we divide by 4.
Why?
Divide by 4?
No. Why?
Good question. Because whenever you change the sign of x, let's say we have x is less than 2. So let's rewrite this thing. Let's move the x over there and the 2 of us. So we add x to both sides and we subtract 2. Right. So what's happening here is it goes from negative x being less than 2 to x being greater than negative 2. So whenever you change the sign of the variable, you have to change the direction it's going. Because if it used to go less than, and you change the sign from x, it's now going to go positive. So that's what I said. That's why I came up with the rule about changing everything whenever you change the coefficient of x. And it works no matter when you're using inequalities or if you use equal signs.
Hmm.
It just is general works. Is no matter what you have, if your last step is a negative coefficient in front of your x, just change everything across the board.
So, I mean, it's kind of, when really you're just thinking the same way, right? It's just looking at signs that mean something, right?
Mhm.
You're dividing out the same way, except for the change.
Right.
I see that's what's happening. I get it.
And that's what I said. Yeah. So if you change the negative, then you have to change the direction. And you change that. Right. So -4 is greater than x, which means that 4 is less than negative x. So our answer is oh, okay. So it wants both of them. So x is less than 6. So it's this one. Continue. There's another part. Oh, okay. So we have a bracket on 6. It's an equal to. So it can't be B. It can't be C because we're in the wrong direction. And it can't be, so it has to be A. Okay, number 2. 4, 5, number 2. It says x squared plus 2x is less than equal to 15. This also has 2 parts, which means we're going to have to graph it too. First step is what? Because it's quadratic, it has to be equal to 0. So we subtract 15 from both sides. Because it has to be it has to be equal to 0. Now, factor it out. What signs go there? Yeah, because the second sign is a negative, one's positive, one's negative, and the bigger answer gets the plus. So what 1 times 15? 1 times 15 is 15. Give me 2 numbers that equal 15. When I subtract them, I get 2. Yeah, 5 and 3, 5 and 3. So since the first sign's a plus, the 5 goes here and the 3 goes here. Is the graph opening up or down? Because the leading coefficient is positive. So we know that our graph, what are my x-intercepts? Very good. And we know the graph opens up, so it looks like this. So what part of the graph does the function want? Look at it wants the part of the graph that's below or equal to 0. So below the x-axis. So we're looking at -5 to 3. Number 9. So the solution set is bracket -5 to 3. Oh, interval notation. What does interval notation look like?
Is it, um, like it has the inequality in it? Like the X,
Is that the interval notation or is that the set?
that not the like the part?
With brackets and parentheses.
The-
As I typed it in there, I should have asked you before I typed it in there, but I still confused you. Yeah, set was basically, this is the difference. When we deal with set notation, we look at this. That defines a set. So when you have inequalities, that defines a set. So we want it from -5 to 3. It can't be parentheses, so it has to be this one. Or 5, number 3. F of x is equal to x over x minus 2. Is above the x-axis for x is less than 0 and x is greater than 2. So the solution set of this inequality, x over x minus 2 is greater than equal to 0, is the set x such that x is less than 0 or x is greater than equal to 2. True or false? So the function here is below the x-axis here. Is this a true statement? So where x is greater than 0 is this. That's, are you sure? Let's see what it says. The function is above the x-axis when x is less than 0. So when x is less than 0, so here the graph is above the x-axis, or when x is greater than 2. That means it has to be below the x-axis between 0 and 2. So is that the truth? Same thing as saying x is above, this says x is above the x-axis when x is less than or equal to 0, or x is greater than or equal to 2. Why is it false? Isn't that the same thing you're saying here, though? Yes. Oh, I'm sorry. they're saying here that the graph is below when x is less than 0. Yeah, so these are the same things. This is not true. This is above the x-axis. So yes. So you're saying it's false. Let's try true. Let me go back to that one. Now, how do we test it? We plot some points, yeah. So what it said here was x is less than equal to 0, x is greater than equal to 2. So we're saying that if I take a number less than 0, let's say -1, and I plug it in there, it's going to give, yeah. So -1, -1 minus 2, those are positive. I mean, those cancel. It's greater than 0. Yeah. Okay, so we have 4, 5, number 4. X minus 4 squared, x plus 6 is less than 0. What is the solution set? How would you graph that? To graph it, what do we need to know? What's the degree? Yeah, because there's 2 there and there's 1 there. The degree is the number of x's we have. So since it's an odd degree, what does it tell us the graph looks like?
It goes
Opposite directions. It looks like this. Since all the x's are positive, this is what the graph looks like. So what are our x-intercepts? Yeah, -6 and 4. So because of our graph looks like, we know that the graph has to look like this. Are there any other x-intercepts? Well, we don't know. Well, we do know this, though. What does the graph do at 4? Does it bounce or does it cross? It bounces because it's an even exponent. And at -6, it crosses. So what this is looking for is, when is the equation less than 0? When is it below the x-axis? Very good. In interval notation. This is 4, 5, number 5. X minus 6, x plus 8 over x less than equal to 0. So how do we graph this equation? The horizontal, the vertical, the x-intercepts, the y-intercepts. So what are the x-intercepts? Very good. So it's -8 and 6. What's the y-intercept? How do you find the y-intercept? Yeah, set x equal. If you set x equals 0, what happens to the bottom? Yeah, so there's none. There is no x, the y-intercept. What's the vertical asymptote? Set the bottom equal to 0. Do we have a horizontal asymptote? Why not?
Because there's two X's on top and
Do we have, so we don't have a horizontal, that means we have an oblique. And what's the oblique asymptote? So if we multiply those all together, we get x squared plus 2x minus 48 divided by x. What times x gives me x squared? X. X times x is x squared. Change it. What times x gives me positive 2x? Change it. So this is my equation. That's my oblique asymptote. Has to be a linear equation. So the y-intercept is 2, and the graph is x. So in other words, it crosses through here, but it shifts up 2 spaces. And we have our vertical asymptote is here. So what's the graph going to look like? Yeah. But we know it can't cross this. So we can pretty much have an idea what it's going to look like. Because we know it's not going to look like this because the points are here. So the graph's going to look something like that.
oh,
Because it has to approach this one going to negative 50.
you still have to plug the points or
Well, if you want to just make sure that's what it looks like.
did you know that?
I know
Yes,
that's what I'm saying. It has a good chance of looking at that. But yeah, we have no horizontal asymptote. We just have that oblique. So what's the question? It's looking for where is the graph below the x-axis? From negative infinity to negative 8. And then from 0 to 6. What did I do wrong? What is it looking for? In internotation, that's plus some points. So at -1 and 1. So we have -7, 7, -1. So it's at positive 49. Yeah, that's what it looks like there. At 4. 4 is -2. 12 over 4 is -6. Wait, where's my intercept here? +2. So this would be a -2. Oh, what, -4, I'm sorry. Let's make it -10. 4 over -4 makes it 10. Yeah, so it's coming down. It crosses at 8. What happens at -10? -16, -2, -10. -16 over 5, -3 1/5. Yeah, so it looks like that's happening there. At 4, we had -6. At 8, we had 2, 16 over 8 is at 4. Okay, we wanted, oh, duh. What?
I didn't say they used to.
Yeah, but that's why they put it down there.
So, okay, wait, how were we supposed, well,
How were we supposed to know? That's a good question.
it's like both ways that you type that, like the initial one would have been right also, right?
Sometimes it'll put a union down there if it wants to.
If it wants you to use.
Yeah, like right there. It put a union there. But up here, well, it's also there.
But did we?
I don't think so.
Well, that's because there's no-
Oh, there's one solution, yeah. Well, let's look at the domain of this function. What's the domain of this function? F of x equals x to the 4th minus 16. We just want to know the domain. So how do you figure out the domain of this? What's the graph of the radical function? So it can't be negative. So the smallest it can have inside here is what? 0. So we have x to the 4th minus 16. The smallest it can equal is 0. Move the 16 to the other side. And take the 4th root. So x equals 2. So the domain, since it's shifting to 2, it goes from 2 to infinity.
Instead of like setting it to 0, couldn't you just like use like the Rosa transformation?
You could, but how would you do? You know, it has to shift to the right. You have to still solve. You have to see exactly how far to the right you go. You know, it goes to the right because it's x minus, but just how far? X to the 4th equals 16. In interval notation, so we have bracket 2 to infinity. What? I use the right bracket. Find the domain of the function. What's that?
What if it's just a print, not a graph? Like, why would it be graph?
Because the smallest number if x equals 2, x to the fourth is 16, 16 minus 16 is 0, square root of 0, 0, and that's valid. So that's why you can include 2 and all the way to infinity. Well, it's a good point, because we have -2 also, -2 to negative infinity. That's a very good point. You have that. Because it's an even function. Very good. Because this is an even function. Whenever you take a square root, whenever you take the square root of here, you have to put a plus or minus in front of the answer because it's an even root. Well, same thing here. So with that, we can go that way, or we can go this way. Because if I take these numbers and I raise it to an even power, it becomes positive. So it's negative infinity to -2, union 2 to infinity. Thank you. So it's negative infinity, comma, -2, bracket, union, there. I brain farted that one. What's the domain of this one? Ooh, this one's even more interesting. After we finish, we'll go back to do number 5 to do them all. 4, 5, number 7. It says g of x is equal to radical x minus 6, x plus 5. What is the domain of this function? Okay, we have a couple of things to look at here. One, you cannot have a 0 on the bottom. So we know that x cannot equal -5. What's another thing we know? That this equation here has to be greater than or equal to 0. So where is it greater than or equal to 0? If we multiply both sides by x plus 5, x minus 6 is greater than or equal to 0, x is greater than or equal to 6. And x cannot equal -5. So the domain 6 to infinity well, yeah, -5 is not in there, so it doesn't matter. What? Is 0. So the domain of the function is, because inside here, the smallest it could be is 0. Well, equals 0 when x is 6, no, -6, so it goes -6 to infinity. No. Oh, +6 to infinity. Anything less than 6 will give me a negative number. I know I have to put this in there in. That is the domain. I just, because -5 is not included in there. Because if both the top and bottom are negative, then the answer is positive.
So why would it be negative in the domain?
Well, it's like it said, the domain would be x is 6 to infinity, negative infinity, oops, let me, something, to -5. So let's say we had -10. If we plug that in there, -10 plus 6, -10 plus 5, -4 over -5 makes it +4 over 5. Yes. Yes. So if we look at this next one with the same logic there, is we know that the denominator is from -infinity to -7, union with 9 to infinity.